In this video, we're going to talk about the domain of a function. So to begin with, the domain of a function is the same as the domain of the algebraic expression it represents. For more on that, be sure to see video 0.4.1. This often is not stated explicitly, but rather as an implied domain, which is the set of all real numbers for which the expression is defined. Basically, there's sort of only two bad things that can happen with an algebraic expression, which is you can either divide by 0 or you can take a square root of negative numbers. Namely, here, if you want to know the domain for f of x equals x squared minus 4, you figure out every place that what x cannot be. Namely, you know x squared minus 4 cannot be 0, but solving that out, you have that x cannot equal plus or minus 2. Similarly, over here, we see that x needs to be greater than or equal to 0, and that would be our domain there. So let's look at the following examples. Let's find the domain of each of the following functions. For the first function, this is just the set of all the input variables. So here, the domain for a would just be -3, that's one of our inputs. That's another input, 0, 2, and 4. For b, we know that x plus 5 cannot be 0, which means that x cannot equal -5. C is a little bit harder to think about because at first you say, well, there's nothing that makes it bad, right? I mean, any value of r works. But here, we're really realizing that this is the volume of a sphere, which means that we need a radius to be positive, right? So, our r is a radius, which means that we need r to be greater than or equal to 0 for this to work. And then finally, for d, we know that 4 minus 3x needs to be greater than or equal to 0. This is an inequality. We have 4 greater than or equal to 3x, which means x must be less than or equal to 4/3. Now it's time to have you try an example, so go ahead and find the domain of each of the following functions. On the count of 3, I'll reveal the answer. 1, 2, 3. So here we have that, again, we just pick out each of the values, the x values here, that constitutes our domain. Here we see that x cannot be 3 because that makes the denominator 0. Here we know that we can't have a negative radius for a circle, so we know that r needs to be greater than or equal to 0. And then finally, for this to give us, for the inside to be non-negative, we need x to be greater than or equal to 16. For more practice in calculating the domain for different functions, be sure to see pages 44 and 45 of the textbook, problems number 3 and 47 through 56. In our next video, we'll start talking about the graph of a function.